Hello, welcome to tutorial 5, Human-Computer Interfaces. Question 1. The PDP-1 mainframe, introduced in 1960, was the first commercial computer with a video display as a standard peripheral. What was the standard display technology on other mainframes at that time? Discuss the changes in display capabilities that the video displays would have brought, and suggest some new applications of the time that would have been enabled by these changes. The standard display technology at the time was the teletype, which was also known as a teleprinter, which printed the output on paper. The changes in display capabilities include blanking and rewriting of words and graphics. The teleprinters cannot erase. The display capability also includes access a 2D space for display. The teleprinters can only print forward. And thirdly, the display can display much faster. The teleprinters are limited by speed of the print height. Enabled by the capabilities, the new applications include examples, screen-based editors, where cursors can be moved in 2D as opposed to line editors, the graphical drawing programs, and the interactive games. Question 2. Various text entry interfaces include keyboards and keysights. How does text entry on a stenotype differ from a QWERTY keyboard, which is faster, and why? A stenotype is a machine where text entry is by coding, which is multiple keys are pressed simultaneously. Each code corresponds roughly to one syllable. Stenotype coding is faster because each syllable contains more than one letter, and therefore sequentially entering syllables is faster than sequentially entering letters as in a regular keyboard. Log stenotype entry is processed by an onboard processor to predict the actual words written. Compare the graffiti-style handwriting recognition on Palm-based PDAs to handwriting recognition on Microsoft-based tablet PCs. Which is one system better than the other? The graffiti system involves writing a stylized stroke for each letter. The letter is interpreted immediately. The handwriting recognition on tablet PC is based on natural handwriting and interpreted in chunks. The graffiti system requires very little space, and users can write letters in the same location on a small device. However, the user has to learn the stylized strokes, and there is perhaps a chance of more errors as the computer has less context to interpret ambiguous strokes. And the tablet-based system is more intuitive and only requires the user to write naturally. There is more contextual cues to determine ambiguous handwriting. However, more writing space is required, and therefore, a tablet is the more appropriate platform. Explain the main differences between continuous speech recognition and spoken command recognition. Continuous speech recognition is used for general text entry. It typically requires a noise-free environment or noise-suppressing microphone to get good accuracy. Furthermore, use training is typically important. The spoken command recognition is used for giving commands to the system. The vocabulary is typically very limited, but the vocabulary limitation is very useful in making the system robust to noise and speech differences in users. Question 3. How does moving a mouse fast affect pointer speed as compared to moving a pointing stick fast? A mouse maps physical velocity to on-screen pointer velocity with a nonlinear scalar factor that increases with the increased physical velocity. A pointing stick converts a physical displacement, which is related to force, to on-screen pointer velocity. also with a nonlinear scaling factor that increases with a higher physical displacement. Moving a mouse fast therefore makes the pointer go nonlinearly faster. Moving a pointing stick faster increases pointer speed more slowly, as the pointer speed depends only how far the pointing stick is pushed and not the speed of the stick itself. Hence, users can experience such kind of feeling like inertia in starting or stopping the action. Question B. Compare the absolute pointing interfaces of stylus, touch, and free arm pointing. The stylus-based pointing has the greatest accuracy, but which is dependent on a stylus. It's also the most ergonomic as users can rest part of their arms on the screen, like while writing. And the touch-based pointing is more intuitive and applicable for young children. It does not require a stylus, so it's appropriate for public kiosk. There is less accuracy in pointing, so writing is not effective and the buttons have to be larger. For the free arm pointing, it's also intuitive and is the only natural pointing interface for very large displays. There is less accuracy because it's harder to determine where a user is pointing at. Also, the pointing is less steady due to the normal slight tremor in arms and is also tiring. Consider an interface where a user points to a screen location by deliberately looking at it, which may be implemented by tracking the user's eye gaze direction. Discuss whether such an interface is good from an HCI perspective. Actually, such an interface is not ideal as the human visual system is normally used for input sensing, not deliberate output action or communication, and such an interface will be awkward for many users. However, the users with severe motion disabilities may benefit from such an interface. Separately, an interface which automatically determines where a user is looking at is fine, as long as there is no assumption that the user is making a deliberate action by looking. Question 4. Describe the display spatial characteristics of physical size, aspect ratio, spatial resolution, and viewing angle. What factors does the display field of view depend on, and why? The physical size of display is typically specified in terms of the diagonal length of the display. The aspect ratio is the ratio of the width to the height, and the spatial resolution is specified by the number of pixels horizontally and vertically. Viewing angle is the widest angle deviation from the perpendicular direction such that the display quality still remains acceptable. The display field of view is the horizontal and the vertical angles covered by the display from the user's perspective. It depends on the size and the aspect ratio of the display, as well as the distance of the user from the display. A bigger display size and a smaller user distance would directly increase the angular coverage of the display. Aspect ratio is important because the human visual field is roughly 200 degree horizontal and 120 degree vertical, so the appropriate aspect ratio is needed for greater immersion. What's the brightness and the black level? In what conditions are these intensity characteristics more important for improving the effective contrast? The brightness is the luminance of white pixels, and the black level is the luminance of black pixels. Having lower black levels is more relevant in dark environments, as the contrast ratio can be significantly improved with a low black level. Having greater brightness is more important in bright environments, as ambient light will reduce or even eliminate any benefit of having lower black levels. For the different use scenarios of mobility, office work, home entertainment, and immersion, suggest which display characteristics are most important. For the mobility scenario, we need a small size and a very high pixel density and a very high brightness. And for the office work, we need a moderate size display, and a smaller aspect ratio may be preferred for reading documents, and a higher brightness as office are typically well lit. In the entertainment scenario, a large size display is preferred, and a larger aspect ratio for widescreen content. Brightness or black levels should be dependent on the environment, and we need a larger color gamut. For the immersion scenario, we need a very large size or close-up viewing display, and we need a illumination controlled display as low black levels are important, and we also need a larger color gamut. Question 5. Discuss the different types of haptic technology, namely vibration cues and 3D haptics. The vibration cues, sometimes marketed as a force feedback, provide simple tactile feedback in the devices such as mobile phones, tactile mice, and gaming interfaces. The 3D haptics enable tactile sensation of virtual 3D shapes, resistive force implemented either by air bladers or actuators. Examples include data gloves and pen-based devices. Briefly describe motion cueing techniques in motion simulation. In the motion simulation, the long accelerations are simulated by tilt to align virtual force with real gravity, and the short accelerations are simulated by acceleration onset cueing, where initially there is a fistful acceleration by the simulator, followed by a gradual and imperceptible return to the neutral position. What are the primary human senses utilized in haptics and motion simulation? In haptics, the primary human sense involved is touch, and in the motion simulation, the primary human sense involved is the sense of balance.